Ladies and gentlemen, today we are going to talk about Unit 3, Note 4. So today we're going to talk about adding and subtracting polynomials. So one thing I really want you to think about when we go into this note sheet is that you cannot add things together unless they are the same exponents. So for example, let's take a look at x squared. Now let's represent x by squares. So here I'm going to have 4 squares. Here I'm going to have 3 lines. Okay, 1, 2, 3. Okay, so I'm not going to go through and do the whole problem, but the biggest thing that I wanted to point out to you is we can't take squares and add them to lines. Squares and lines do not add together. Okay, so we can only add squares, and then we could add those squares to these squares over here. Okay, so you can only add things together if they have the same exponent. So let's go ahead and take a look at a couple of these things. So when we're talking about adding and subtracting polynomials, you add polynomials by combining like terms. But like terms, remember, mean you have to have the same exponent. So you add them together by like terms. And you want to make sure that your exponents are going from largest to smallest. Okay, that's what standard form is. So we're adding like terms. Basically, all we're doing today is putting things into standard form. Let's kind of take a look at what that looked for us. So we want to combine these like terms. So what I want to do is I want to combine like terms, and I want to put it in standard form. So I see that x to the third power, that's my largest exponent. So I want to take anything with x to the third power and add them together. So when I add 4x cubed plus 3x cubed, I'm going to add the coefficients, and then when I add them together, I'm keeping the exponent the same. So I'm adding the coefficients and keeping the exponent the same. When you are adding like terms, you do not add the exponent. Okay, when you're adding like terms, you do not add the exponent. So now I've combined those two. Now I'm taking 8x squared minus 5x squared. I'm going to subtract those coefficients. 8 minus 5 is 3. And then when you add the x squared, that's going to stay as x squared. Okay, negative 3x plus 5x. Negative 3x plus 5x is going to be 2x. And then 8 minus 12 is going to be negative 4. So I combined things with the same exponent, okay, but when I combined them, I did not actually add the exponent. I just added the coefficients. Let's take a look at number 3. We have 3x cubed minus 2x cubed. 3 minus 2 is just 1, and then x cubed. Okay, what I didn't see was that 5x to the fifth there, so that needs to come before x cubed because that's a larger exponent. My next highest exponent is x, so I have negative 2x minus 4x. When I combine those, negative 2 minus 4 is negative 6, and again, keep the x's the same. Then we have 4 plus 5, and that is going to give us 9. So that right there is your final answer. Alright, let's take a look at a couple more of these. So we have 3x cubed plus 2x cubed, add the coefficients, keep the exponent the same. Then we have 2x squared plus 5x squared, add the coefficients, keep the exponent the same. There's my x. Okay, then next I just have that minus 3x by itself. Again, I want my exponents going in descending order. And last but not least, I have negative 12 minus 6, which is going to give me a negative 18. Taking a look at one more. Here's our largest exponent. That comes first. Then 4x cubed plus 5x cubed. We're going to add the coefficients to get 9. And then keep that exponent the same. Negative x plus 4x is 3x. Minus 4x is just going to be x. Oops. It's just going to be a negative x. Sorry. Come on. And then last but not least, we have that minus 2. So that's kind of that looking at combining like terms ideas. Now let's apply it to what we're doing today. So today we're going to learn a method to add and subtract polynomials. So to do that, we want to line our terms up vertically, putting them into columns. Okay, so notice I have an x squared column, I have an x column, and I have a constants column. So now I'm just going to add down the columns. 4x squared plus 2x squared. I'm going to add the coefficients, keep the exponent the same. 3x plus 2x, add the coefficients, keep the x the same. Negative 2 plus 1 is negative 1. So now we're going to take a look at that idea. We're going to actually set it up ourselves. So let's take a look at number 5. We want to add these two together. So I'm going to write out that first polynomial since it's in standard form. So I have 3x squared minus 4x plus 8. Now this guy is not in standard form. Okay, so not in standard form, that means I want to put this x squared and I want to line that up in my x squared column, keeping it as minus. And then I have plus 2x, and then I have minus 5. So I just lined up each of them in the column for that second polynomial. So now I can go ahead and I can add down the columns. So 3 minus 7 is negative 4. Negative 4x plus 2x is negative 2x. And then 8 minus 5 is 3. Okay, so again, I'm adding the coefficients, keeping the exponents the same. Let's do the same for number 6. So we have 5x squared minus 3x plus 4. So for this one, I want to put the columns in order. So I'm going to put the negative 3x in the squared column. I'm going to put the 6x in the x column and the minus 3 in the constants column. And now I can go ahead and add down. 5x squared minus 3x squared, that's going to give us 2. And then we're going to keep the x squared the same. Negative 3x plus 6x is 3x, and 4 minus 3 is 1. So we have 2x squared plus 3x plus 1. And that is your final answer, okay? One thing you want to check before you move on is you really want to make sure that your answers are in standard form. Let's take a look at subtracting polynomials. So when you subtract polynomials, you want to make sure you go through and you change the signs of everything after the minus sign. And then you're going to add the two polynomials. So there's going to be a parenthesis after the minus sign. Every single term in that parenthesis has to change. So let's take a look at what that would look like. So let's take a look at this guy. So before I go lining up my columns, I want to take this negative sign here. Pretend there's a little negative 1 out front. So I'm going to take that negative 1 and I'm going to distribute it into each thing. So here's what my problem is going to become. I have 4g cubed minus 5g. Now I'm going to make this plus, and then I'm going to change this. So it's going to be negative 2g cubed minus 4g. So I just went through and I changed the signs of everything. Now I'm ready to set up my columns. So I have 4g cubed minus 5g. Now I have a negative 2g cubed because I distributed in that negative sign minus 4g. So now that I've lined up my columns, I can go ahead and add down. Negative 4 minus 2 is just 2, and then g cubed is going to stay the same. Negative 5 minus 4 is going to give me negative 9, and then that g is going to stay the same as well. Let's take a look at number 8. So for number 8, again, we're subtracting. So we want to think of that as a negative 1. So all of those signs are going to change. So we have 3n squared plus 13n plus 5n. And that's going to be plus, and I'm going to change those signs. Negative 7n minus 4n cubed. So I'm going to go ahead and I'm going to write out our first polynomial, 3n squared plus 13n cubed. We should write that in order, huh? That'd probably be smarter. So let's put that in standard form. So let's put our 13n cubed first, and then our 3n squared, and then our 5n. And now I'm going to line those up under the columns. So I'm going to put negative 4n in the n cubed column and negative 7n in the n column. And now I can go ahead and add down because I've already distributed that negative sign. 13 minus 4 is going to give us 9, and then n cubed is going to stay the same. Well, because we're not adding that 3n squared to anything, it's just going to drop down and be 3n squared. 5n minus 7n is a negative 2n. Again, keeping those exponents the same every time we do it. Let's take a look at number 8. So for number 8, we want to go through and we want to change the signs of everything. So I'm going to look at this as being multiplied by a negative 1 and distributing that in. So my first parenthesis is going to stay as 5y squared minus 3y plus 8. Then I'm going to change this. And I'm going to change the sign. So it's going to become a negative 4y squared, and negative 9 is going to become positive 9. So now we're ready to set up our columns. So I have 5y squared minus 3y plus 8. Now I want to change the signs of everything. So I'm going to put the y squared column here, and then I'm going to put the constant column here. So again, now we can add down our columns, keeping our exponents the same adding our coefficients. 5 minus 4 is 1, so we have y squared. Again, this 3y is just going to drop down. And then 8 plus 9 is going to give me 17. So this right here is our final answer. We can't combine any more like terms because they're already all the same. Let's take a look at this next one. So we have a subtraction sign again. So what I'm going to do is I'm going to look at this as being multiplied by a negative 1 and distribute that into each thing. So this first parenthesis is going to stay the same, so xy plus 3x squared minus 5y. Then the second parenthesis, I'm going to change it to a plus, but then I'm going to change all of the signs. So every single sign in that second parenthesis switched to the opposite. It doesn't necessarily mean they're all negative. It means we switch to the opposite. So let's write out our first one. And we can't really put this one in standard form because it involves two variables. So I'm just going to write it out as is. Now I'm going to line up my columns. So I have a negative 4x squared. I'm going to put that in my x squared column. A positive 2y. I'm going to put that in my y column. And a negative 6xy. I'm going to put that in my 6xy column. Now I can add down the columns. Negative 8 minus 6 is going to give us negative 14. 3 minus 4 is a negative x squared. Negative 5 plus 2, that's going to be a negative 3, and then the y. So notice all of the letters stay the same. The only thing that's changing is the coefficient surrounding them. Okay, let's take a look at this word problem. The total number of public school teachers, T, consists of two groups, elementary, E, and secondary, S. From 1992 to 2003, the number in thousands of secondary teachers and total teachers could be modeled by the following equations, where N is the number of years since 1992. So, to get the number of elementary school teachers, here's what I know. The number of elementary school teachers is represented by E. So to get the number of elementary school teachers, we can take our total number of teachers and subtract the number of secondary teachers. Either you're an elementary school teacher or you're a secondary teacher. Okay, so the secondary teachers, we can take the total, subtract that. That will give us the number of elementary school teachers. So let's write that out with the polynomials given. Well, T is 58N plus 2,401. Then we need to subtract the secondary, which is 29N minus 949. So now we can go ahead and we can line that up to subtract it. So what I'm going to do is I'm going to look at this as being multiplied by a negative 1, and I'm going to distribute that in. So now I have 58N plus 2,401. Then I'm going to change this to addition and change each of these signs. So it's minus 29N plus 949. So now I'm going to go ahead and set up my columns. So I'm going to write my first equation, which is 58N plus 2,401. And then I'm going to write my new one, which is a negative 29N plus 949. So now I can go ahead and I can add down my columns because they're all set up. So 58 minus 29 is going to give me 29, and again, my ends are going to stay the same. 2,401 plus 409 is 3,350. So this right here is how we could figure out the number of elementary school teachers. So that concludes your note video today. Thanks for listening, and show me your note sheet when you are done.